In Sweden, agriculture is a very small business, but next speech represents probably one of the most important industries we have in Sweden, the forest industry. And to talk about this matter, we have no less than Professor Magnus Karlberg from Luleå University. I think we give him a warm applause. Thank you. So tell me, Magnus, how did it come that you was interested in research in forestry and agriculture?
Yeah, well, I actually, because I'm a mechanical engineer, so it's not really spot on my, let's say, the typical context for me, but it was a few years ago, and for some reason we started in some I think it was in some student project with this, and I saw that with all the focus on sustainability and all of that, I see that forestry, and also for that matter, agriculture, is sort of spot on when you're dealing with sustainability issues. So it sort of catched my interest, and since then I've been more, doing something at least in this area also.
Thank you, and the scene is yours.
Thank you. Okay, just a few words about me also. So I'm professor then, and the subject is computer-aided design. So as I said, I'm a mechanical engineer, so maybe we will move a little bit away from things that you've heard before, but still I'm the head of the division of product and production development at Luleå University of Technology, saying quite a lot about what we actually do. We work with product development. And also the director of the Master of Science program in Mechanical Engineering at the same university. So that's my sort of two main responsibilities then. Just so that you know a little bit of who I am also. I think we'll start, as I said, sustainability and all that, which has been sort of, for me, very, very interesting to work with. And we know, just to remember a few of the mega trends, which also is sort of still things that actually make us go and take the decisions on what to do research on in the future, and for me also, of course. But we know that the population will increase, and it will increase quite a lot. We don't know exactly how many billion there will be, but it will definitely increase a lot of years ahead. Due to that, of course, follows a lot of consumption. There will be much more products in the society, and there will of course, be much more consumption, whether we like it or not. To do that, of course, there need to be much more research outtake. We need to use more energy. We need to use more material. To a certain limit, of course, where you cannot do that anymore. But that's the trend, what we see today at least. We also see urbanization and these mega towns. Up to 60% population today lives in urban environments. So we know that this is continuing. Then for how long, we don't know. And then we have the climate changes, which we all know, and there is a huge discussion about that and yeah, what that means and all that. For instance, this UN declaration of the report talking about something really need to change the next 10 years or so. Otherwise, it's irreversible. You cannot go back, sort of. So this is of course very interesting challenges for us, but let's bring it down. That's why I think that forestry and also agriculture is an area that is really interesting to work with, because I think here is where we have at least part of the solution to this. So, as I see it, forests, they should be the key resource in the future, which you have heard, sustainable, circular, bio-based economy. This is all of the buzzwords that I could put in the same sentence. But you hear this every now and then, don't you? And I think that's why forests is very interesting to work with, because it's already circular and it's already bio, I mean, per definition. So it's a good start at least, isn't it? So it's a renewable resource source. And actually, as they say, what you can do by oil, you can do by woods. So you can basically do anything with this product. So it's an amazing product in that sense. And it also has an effect on all dimensions of sustainability. So it's not only environmental effects, it's also economical, it's also social effects, of course. So I think it's a great start for research to work with forests and also agriculture. If you look in Sweden, it's actually really a cornerstone in the economy for Sweden, because it employs around 200,000 people in Sweden, which is quite a lot actually. And we have a lot of exports, 130 billion Swedish crowns yearly, and then of course there is also a huge investment in this area due to that also. And if you look at forestry machinery, we also have some turnover in that, of course. So it's a substantial, it's a very important industry for Sweden, actually. If we look at some of the particular challenges in forestry which we focus on, productivity is always there, and the illustration here from Skog show that from the 1950s and forward, you have had the mechanization and also outsourcing doing that, which have made sort of the productivity increase quite a lot. But then lately, we are not sure that we can continue to sort of increase the productivity in the same way. And a lot of that is due to operator limitations. I mean, human beings can do just so much. That's one of the main reasons for productivity limitations today. There are also, of course, challenges in environmental impact, not only in pollutions in combustion engines and all of that, but also ground damage, which is a really important issue in forestry. We are not allowed to damage the ground too much. If you look at work environment, there is also a lot of trouble there. Actually, it's a quite dangerous work in forests. Also in agriculture, as I know, there is a lot of sort of mortal things going on even. I think it's by far the most mortal sort of work environment that you can find in Sweden at least. So, but then you have vibrations. Working in the forest today is kind of solitary, it's monotone work, quite a lot of it, and it also a lot of mental strain that you have to be really focused for a long time and all of that. So it's a sort of a tough work environment for those operators also. What we also see in the future is, of course, that the customers to these products will not be, as we heard the previous speaker also talk about, they will of course want to have a certain tree with a certain sort of properties, both internal and external properties. So in the future we see that we need to scan each individual tree to actually know more about it, so we can sell it for the best sort of profitability, or whatever reason we sell it. So meaning that we need larger volume to be able to use the wood in a better way than today for sustainability then, and also more diversified range then of the products. Another issue is also profitability, and that's within the whole value chain then, and that's also a challenge that needs to be addressed within this field. So the question that we have asked ourselves, and many more than us of course, but which are the enablers for this then? How should we meet these challenges that we see, both the mega trends and also the specific challenges in forestry? And as I see it, it's the smartness. We also heard previous speaker talking about smartness, and I think that's at least one part of the solution. And then the question is, what is that? And I will talk about two of the things that I believe is the most important part. And one thing is the autonomy. We need to increase it quite a lot. And also make use, of course, of renewable energy when we do it. So we don't miss that during the way. And then there is another trend that's been going on since, at least we have worked on it since the 90s or something at Luleå. And it's performance-based business models. We need also to take care of the business models because they have a huge impact on the incentives created. So I will talk just a little bit on that one. That's usually a complete speech for me, but today it will be just a few slides. So I will focus mainly on point one. So let's have an outlook and look at some other industries and what's going on there, because it's always nice to do that and see how far they've come. Today, you see, this is an example from Volvo Cars. So it's their concept vehicle, Volvo 360C. It's an autonomous vehicle. it's electrified, and it's connected, and that's three of the words. And I think this is one of the areas which is sort of moving fastest forward. We know there will be autonomous cars out there. It's just a few. I mean, the technical solutions are almost there, but you have, of course, regulations and other things, security issues, who takes the responsibility, who takes, when things happen, who are the responsible person and all of that. There's much of those things that need to be said. But this is an area which is moving forward fast. Maybe not looking at forestry machines, they don't look like that. They rather, it's more interesting to go and look in the heavy vehicle situation. This is from Volvo Trucks then. It's the same thing, it's an autonomous truck, it's electrified, and it's connected. So they have removed the operator from this vehicle as well. And as far as it's of course not only Volvo doing this, it's a lot of competitors out there doing the same thing, but common for them is that they remove the operator from the vehicle. And that's where you find the productivity gain, of course. And when you start to have ranges of these close to what you can do with combustion engines, and also when you have the infrastructure of how to, where you can load your batteries and all of that, then these concepts are much more interesting for commercial, of course, situations. So this is interesting. We have been working on another situation, articulated horses. I don't know if you like machines as much as I do, but I really like these ones. I mean, this is not, we start working on this machine together with Volvo Construction Equipment. It was 2014. 2016, then they launched this machine. It was HX01. It's a completely autonomous, again, it's the same thing. It's autonomous, it's completely electrified, and it's connected also. And of course, where you used to have a driver, an operator, you put material there instead. That's much smarter, of course. Why should you have an operator going around sitting in the machine where it's vibrating also a lot and whatever other bad things that might happen to you when you're on these machines? So of course, Volvo Construction Equipment, they saw that of course we can remove the operator and have more material going on, and then you can start to think about the mobility instead, and how could we then work with moving around different kind of materials in a certain site. So they have gone even one step further with this, and they updated it just to make it more, let's say, use their own internal components and all of that, and also they built 8 of these machines for the initiative. It's called Electric Site in Sweden. It's a huge sort of initiative. It's Volvo CE, but it's Skanska and the Swedish Energy Agency is involved in that one as well, where they are demonstrating this on a real site, where you can actually move around material much more efficient than you do today. And you do it without operators. And with this, of course, it's not only profitability, of course, close to zero emissions. Of course, you still have something that's not good for the environment, but emissions, as far as emissions go, it's very, very low, very low. And you can start thinking about completely new ways of doing things. Instead of having, operators maximum working with 8 hours, and you have to have these breaks and whatever, you can have machines working 24/7. You can have a much less human interaction. So I mean, this isn't sort of a joke, this is happening right now. So the question is just whether to go for this, or how long time it will be until we have this also in forestry, is my view of it at least. But it's happening in other fields, so we will see much more of this in the future, of course, definitely. If we look at challenges, specific challenges regarding autonomy in forestry, then of course, if you look at the regular cars, and also in this case articulated haulers, you have certain things that is maybe easier in terms of environment. If you look at forestry, you have to go off-road, for instance, and going off-road means something. You really have not too many guides that you can follow. you have a lot of obstacles, you have stumps, you have trees, you have stones, you have slash, and you have whatnot. You have things going on, changing over seasons. Very often you are remote, which might have an impact on the connectivity. You may have long distances to spares, meaning that you have to really be careful about the reliability and availability of your product. If you're going far away and something happens with your autonomous vehicle, it will not do any good if it's standing still. So, then the operations themselves isn't that easy actually. It's one thing to move. I mean, if you have loaded your articulated hauler and you just move between A and B, that's one thing. But if you're going to grab trees and you're going to saw and you're going to do a different kind of operations, mounding and whatever, those are operations that are not too easy. So that needs to be taken care of at least. And then we have this sensing part, well, this information that we need in the forest as well. How do we get that? Both the internal and the external information, and information that we can store for the history, as for instance this really neat system that we heard about just previously. Yeah. So these are some of the specific challenges that we see when going autonomous in the forestry operations. So that's why we have focused on some of the central research areas, which you can see here. So for one thing, we need to be able to identify certain objects and properties in the woods. For instance, when type, size, and distribution and position, we need to know that. If a machine is going to take decision on certain things, for instance, how to navigate, it needs to know if you have a huge stone ahead of you, or if it's very wet area, or you're driving to, which will cause a lot of damage to the ground or whatever. So there are a lot of that sort of research going on. We also need to be better at information sharing, and it's not only within a certain operation, it's also in between different operations, and it's also between different value chain partners, because you need to share the information within the whole value chain to make profitability for each and one of them, of course. Navigation, it's also an issue which I will show you some example of. Reduction of soil damage is a focus area in Sweden today. We need to be better and not disturbing the soil more than we have to. And we need more new energizing methods, as I said. As we see, even the heavy machine industry seems to go for electricity. I'm not sure that will be the total solution. I think it's a part of it. I think we need to look at that combined with some other ways of getting fossil-free energy fuels, for instance. And then with this, of course, we need to start look at completely new concepts also. I was thinking about this machine where you distributed different fertilizers. What's that called? Like that, I think so. But of course you will like to do that and be precise with it and not distribute it sort of randomly. This needs to be taken care of both on the machine level and equipment level, of course, and together with new methodologies and all of that. So these are some of the research areas that we are interested in and working with. So I will give you a few of the results that we have so far. We have been when I started working in forestry a few years ago, I was completely sure that we will be able, going out on a field and looking at the stumps and stones, it's very easy for us to say which one is which. That's a stump and that's a stone and that's slash. It's very, very easy for us. And of course I thought that was equally easy to tell a computer that, which it was not. It was really, really difficult to make the computer understand it. So up today we work at least with stump identifications. Today we have algorithms that we can say that, okay, and with space of time of flight camera, it's like 3D cloud data. So we can, based on that, be able to position certain stumps on a field. So that's one, and that's Dr. Håkan Lideskog that has worked with that. We have been involved in a project. We have Ola here also, and they're working with this at SLU and also UMU. Eddie Wadbro and Ola Lindros and also Håkan Lideskog have been working with navigation. And the question is, what are you optimizing for? Because if you're only optimizing for economic sort of profits, then you will have one route that's optimal. If you take into account things like environmental issues or other ecosystem services as well, then you will have another route that's optimal. So the question is what you put in to start off with. If you want to be sort of, you don't want to damage the ground too much, but still be kind of profitable, then you will have one route. And if you have some other trade-off for your objective function, then you will have another route. So, but the main idea is to, of course, do a lot of optimization before you enter the site. And of course, when you enter the site with the best route that you have, of course, you will not know everything, so you have still to take you have to learn about what's going on, because of course there is a huge stump or a huge stone exactly where you were supposed to drive, and then you have to make local corrections on board on the machine also, and that's what the right-hand side says. For instance, it have rained a lot or whatever, so it's completely wet, so you couldn't drive in that particular spot. So that sort of research is also ongoing now. Very interesting, very, very interesting. We have been working, this is one of the procedures for all of those that are in forestry. You know that in Sweden we do some site preparation before planting, and this is one of the most commonly used site preparation methods. It's called mounding, where you do these mounds with a machine. Basically you have a machine, a forwarder running by an operator today, and then you have this equipment doing mounts in an equal distance, like 2 meters by 2 meters after each other, like that. And those machines today is not too smart, they do it sort of evenly like that. But the problem is when you have a lot of obstacles, then a lot of these mounts will be, no, you cannot plant there, you cannot use them. So you have to do more, and then you damage the ground more. So this is one of this is Håkan Lideskog also has worked with methods for, if you just could sort of positioning this mounding equipment, both longitudinal and also transversal. If you could do that, then you could do, each mounding would be sort of a good spot to do the planting on. And you don't have to, you could have sort of a much better success rate. So we have studied that. This is an illustration where you show that, I'll take it a little bit slow, that the lower, lower line, the black line would be a situation where you are in today's mounding, where you do a mound and then you wait for 2 meters and you do another, like that all the time. And if you have on the x-axis here, you have the how big fraction of your site that is has obstacles. So if you're moving up, you see here like 50 or 60% obstacles, and that's a lot of obstacles. That's a lot of stones and stumps on that area there. Then you basically have no success rate, so you have success rate here. So if you enter from 50% and more than that, then you will basically have no really good, it will have a very, very low success rate on your mounts. If you instead could position your equipment transversally and longitudinally as you wanted, then you have this potential, then you can stay, not completely 100, but you can stay almost 90-95% up to here, and then of course to some extent it also moves down. So you have a huge potential here, where you could, if you could use, just by changing position of the mounting equipment, you could really go from like 10-20% up to 80-90% quality. And that's a huge benefit, of course. We have been involved to some extent. This is some illustration from Pedro Lahera at SLU, where we see that operators today are quite bad at managing cranes. I mean, one crane is basically enough. If you put 2 of them there, it's very, very difficult. You can try it yourself if you have one of those equipment. I mean, it's really, really difficult to do this as a human being. A computer could probably help you doing it. So Pedro has been working with some of the algorithms for at least doing this semi-autonomous. But in the future, this has to be done autonomous if we're going to remove the human being from the machine. We don't want the human being there. So there are really interesting things going on here where you can start using several cranes which are at least aided by computers, but in the long run doing this kind of work completely autonomous. We have been building this off-road vehicle research platform at LTU to be able to study. I mean, it's one thing to work with this smaller machine when you do the sort of building the algorithms and making sure that they kind of work, but then at some extent you need to go out in the woods and do things for real. So we have been building this platform. This is actually where we have mounted a mounting equipment, but you could of course mount cranes on this one, and you see you can have other tires, or you could have different kind of contact organs, as we call them, on the machines, so we can test different things. We can put on also planting equipment on it. And today this is basically where we are at for now, but we are equipped, we are sort of preparing it for some of the projects that we have run, but as you can see, this machine doesn't have any room for any operator at least, and that's important. There are some new initiatives going on that can be interesting to know about. For instance, we have this Auto2, it's called Automation for Autonomous Off-Road Mobility. It was a Vinnova-funded project that was actually quite recently approved, which will take care of some of these challenges. Here you have a forest machine, and then we have a work package dealing with the driving things, how you go from A to B autonomous. That's one work package. It's also the safety issues. Of course, if it drives around, you need to take care of the safety things. You will have animals running into the areas, or human beings, or whatever, so you need to take care of that. That's one work package. We have, in that case, they will also have a work package working with remote control, because we of course think, as most do, that that's the first step. You go remote first, and then you go completely autonomous in this next step. And also we have, which is really important that we start, because this is sort of a paradigm shift in terms of how machines are used in forestry today, and nobody really knows how that fleet should look like. I mean, should it be a fleet of very small machines and many of them? Is that better, or should it still be, as we heard before also, larger machines and fewer of them? I mean, when you go autonomous, you don't really know which the best system is, so we need analysis. This is a really important part also. And we also have some work package dealing with security laws and regulations, which, as for instance in car industry today, that's basically the main obstacle, I would say. We need to take care of that also. So that's addressed in this project as well. And test platforms. We have several test platforms from both Skogforskning and LTU, and KTH here in Stockholm has also a platform. So there are several partners involved in this one. So this is very interesting, 2-year project. Then we have another, which is actually, this is not it's not forestry, it's agriculture. And then we will use, we still call it a drone. It's just that it's an 8-ton machine drone. And it doesn't fly though. It's still a drone in my mind. But this is a project where we're going to do self-learning agriculture machines. They're going to learn by themselves how they do this decision, take some of these decisions. Because we believe also in agricultural, we will have in the future, the operator will probably be communicating through one of those instead of sitting on the machine. I have really difficult to see why you should sit on the machine in the future. It seems very dangerous to me at least. But then of course there is a lot of tools needed for this one. So this is a KSLA and the SLO Foundation that's funding this one. It's just starting up. There is another initiative also, which is called, it's a MISTRA initiative, which I'm not involved in. It's called Digital Forestry or something like that, Digital Forests or something like that, which is a huge initiative in Sweden, which also address some of these issues, which will be really interesting to follow the next 4 or 5 years to start off with, I think. Okay, I will end with I see that the clock is running away as usual. I will just mention also this with the performance-based business models, because I've spent 10 of my years doing research in this area, and I think that this is something that you should also embrace in forestry and maybe also in agriculture. Performance-based business model, it's when you do businesses where the provider takes one or several functions. You do business on function rather than the product that you use to provide the function. So one of the most famous examples would be power by the hour that Rolls-Royce introduced in the 60s or something. That they say, you don't need to buy an aero engine from us. We make sure that you have the drag force that you need every hour. So that's that concept. And the interesting thing is that how you realize that function, how you make that happen, is completely the provider responsibility. And the ownership, whatever you need to do it, all the enabling subsystems that you need, and the research has shown that you usually need some hardware, software, some service support system, and some management of operation system. It remains at the provider responsibility throughout the life cycle. So if you're going to use steel to make profit, you will own that steel throughout the life cycle. It's a completely different business model than what you have in the regular product oriented ones. And what happens when you do this? I just show you a few examples so that why I think this is important to start talk about in different fields. This is one example where it was the architect of when they rebuilt Schiphol in Amsterdam. Then the architect was sort of annoyed, saying, "Why should I put the specification on each of the lamps in this roof or whatever it was in the terminal building?" So he said, "I want some just level of light in this building and on certain times of day and whatever." And Philips said, "We can do that." So Philips took the whole responsibility to make sure that you had a certain light that the customer wanted. And the bill for the energy went to Philips. And that's where the incentives becomes interesting. So, and that's the illustration that you see here. So when they started this project, they have a bill here, whatever it was, 400 kilowatt hours. And they said, it should be possible to reduce that, shouldn't it? So Philips, of course, started to think, if we have the bill, then we would like to reduce this. Still, the customer would have to have a certain lux per hour, or whatever it was. But they start with some smart technology and control algorithms or whatever, and they reduced it by almost half or something, because they had the bill. So that's interesting. That's one example. This is one of my favorite ones. You might have one of these. I had the car illustration before. The degree of utilization of regular cars today is almost nothing. Cars are standing still. Okay? So what the providers know today will happen is, of course, that we will not, especially if you're in a mega town as we saw, it's really, really annoying to park your car, and and then you have to own a space where you park your car, because it will stand there for 95% of the time. If we all have to own a car, what will happen is, of course, that I still want the mobility that I have today. And the car industry says they have understood that, if we start to charge for mobility instead, we own the cars ourselves, and we make sure that you can move around as you want. Then we can start by almost reducing, let's say, half the fleet. You can do the same work. Half the fleet or something. That's a lot of steel that you don't have to bring into the system. That's very good for the environment. This is a really smart system. And then it's not only that. They say like this also. It's not only that. Today it's Monday. Today I would like to. I have to drag some big. I need a huge car for this and that reason. And tomorrow I just need a smaller car. So you have different needs. And what we do today is that we buy a car that is almost good for everything. Tomorrow, when you go outside your work, it will stand the correct car there for you. And it will drive you between A and B autonomously. There is a huge effect if you start going for businesses like this in terms of sustainability. And that's what we have actually, because this is up now, it's been almost like speculations that will it or will it not. So we did, this is a quantitative study. This will be my last slide, I think, because now we are hungry. So on the y-axis we have environmental impact. I don't give you any sort of numbers, and on the x-axis we have costs. This is a situation, it's a simulation model though, but let's say a society where you have a certain output. And only by changing business model. So of course we want low cost and low environmental impact. This is where we want to be, isn't it? Okay. If you look at the case where we optimize for a traditional business case, you just sell products as usually. Then you would end up here when you optimize for that. What we saw is that the only thing we did different was to bring in a performance-based business model. Then we get a situation like this. It's not because it's not zero here, we have zoomed in, but it's what we showed was that you can get 50, in this example now, 15% better economy, it was 50% lower cost, and at the same time, it was 50% less environmental impact. And that's a lot of gain, which we can share within the value chain. So I think this is important and is here to stay, that we will go more performance-based in the future. Some industries are already getting here. So, just a few conclusions then. Automation, I see that there are definitely some of the most important challenges in forestry we can solve by automation, I'm sure of that. There are good opportunities to follow other actors in the field, but there is still a lot of research needed, especially to the particular problems within forestry. There are some good initiatives ongoing in Sweden. Of course, there are other initiatives abroad as well. And I also, as my final speech here, I really believe that transition into more performance-based business model will help. And I think that in agriculture, and I think that in forestry businesses as well. So thank you. Thanks a lot.
Very interesting, and before Humbert tears apart, I think we need to have answers on some questions. Or? No hands. I thought it would be a storm of hands. Okay.
Are you thinking about risks for
Micken, please, come.
Yeah, we have experienced a lot of fire in forest this summer. Is it possible to improve with fewer people in forest, can improve this?
That I haven't actually, I don't think I've really thought about it, but now when you mention it, I mean, that will be definitely something, could be a huge challenge, because it will definitely be less people in the forest, and then what happens when it takes fire? On the other hand, I guess a machine can be better at finding possible fires. So if we equip it with something to sort of make some early, actions to prevent it, maybe it can be done. So, but it needs to be addressed, and I don't think anyone in research at least have addressed it so far. But it's a really good question, really good question.
Pat? Being a very stone-rich forest owner, I wonder, why has computers difficulties in separating stones from stumps? It's very interesting.
Yeah. I thought it was easy, me too. It's basically, I don't know, I mean, we know now how to go forward to solve the issue, but because I think the easiest way to do it is by machine learning algorithms, so that's the way forward. But we didn't, for some reason, we didn't go that way. We used sort of rule-based algorithms, so that's probably, so it will be done, but and I don't think it is too far off. It's just that too many people haven't done it yet. So, but it's there. I don't think it will be a big issue actually.
Okay. I actually know some project who work with these forest fires. They use LoRaWAN, this small band. I don't know the English word for it. In the forest. Okay. To work with that one. Okay. Very interesting, and it's. I think we will have a great future in autonomous Vehicles, the problem is, I think, the humans.
Yeah, definitely. It's always the humans, isn't it?
We are the problem, actually. But here is an old one, used in forest industry in the very beginning, so it's a Massey Ferguson.
Thank you, thank you.